Welcome to today's class. Today we shall be discussing Introduction to Machine Learning. Machine learning is actually one of the major areas, research area of artificial intelligence. What are the outlines we'll be considering today? One, what is machine learning? Types of machine learning. And of course, we'll look at various algorithms in machine learning. Machine learning simply is the study of computer algorithms that improve with experience, okay, that automatically improve with experience. The life without machine learning, you remember those days when there's no facial recognition, when there's no voice recognition, when the search engines were not really effective, okay? So those are the days without machine learning. Then with machine learning now, sometimes on Facebook, for those of us that are on Facebook, we can see that Facebook sometimes suggests our friends for us, friend suggestion. And let's say on Netflix, sometimes you are done watching a movie, and Netflix is trying to tell you that you also want to see this movie. That's because of the classification that has been done. Netflix is trying to say, since you already like this movie, then most likely you like this movie because of the 75 to 100% similarities. So that is machine learning with you. And of course, maybe on Amazon, on any of these website where we purchase items. It's possible you are trying to buy a tie. Then, of course, the computer is suggesting to you that you also need a suit, you also need a formal shirt and all that. That's because of classification algorithm, okay? So, what is machine learning? Machine learning is the study of computer algorithm that improves automatically through experience, the study of computer algorithms that improve automatically through experience. So the goal of a machine learning is to develop methods that can automatically detect patterns in data and then use to uncover patterns to predict future data or other outcomes. Then I have here, machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve their experience without being programmed, okay? So types of machine learning. I have in my slide today three types of machine learning. One, the supervised learning. Two, the unsupervised learning. And three, the reinforcement learning. We'll take them one after the other, the supervised, the unsupervised, and the reinforcement learning. Okay, so in supervised, there's always a known data. Like, look at this example now. I tell my computer that this is an apple, okay? Then I feed it to you and I say, okay, what is this? They say, these are apples. So next time when I put this data to my machine, it already knows because I've been able to label this data that this is an apple, okay? So I can now tell this, I can now put a new data to my machine and say, what is this? Then the machine says, it is an apple because it has known their experience, where the data that inputs in my computer. How about unsupervised learning? Unsupervised learning deals with pattern. Pattern deals with structure. Okay, now so I have different fruits, mango, apple, and I feed it into my computer just for my computer to predict which one is this. Is it mango? Is it apple? Then the machine tells me I can see a pattern, and from there it says, oh, it is an apple. Okay. Whereas we'll take this again so as for us to understand that, of course, when we talk about machine learning, it's more than the theoretical part. We have to learn, we have to write a lot of code using Python. So this is an introductory class. From there, the next class we'll talk about the packages we have to use on our Python programming software and all that. So now, reinforcement learning is basically learning from experience. Let's assume you have a child, a baby. You want the child to know that when the pot is hot, you don't touch it. Or let's assume you light up a candle. So from there, you can just let the hand of the child or the baby touch the hot pot. The moment he withdraws, then he has learned from experience. Next time, he doesn't touch the pot anymore because he knows that, oh, this hot pot, we actually get him or her born. So reinforcement, I put an input. So the input says, it's a mango. No. Then it's noted. It's, let's say, it's cassava. No. Then it's noted. It's an apple. Yeah. So it learns via experience. Okay. So differences between supervised and unsupervised, I said there's a direct feedback, there's a label data, there's a predict output. That's for supervised. Whereas from unsupervised, they are non-labeled data. Okay. They are hidden structures. It uses the structures and the pattern to predict the answer. Okay. And of course, there are no feedback. Whereas I explained that reinforcement is learning from experience. Okay, you let the computer make mistake, then from there it learns from the mistake. From there you can always predict, oh, this that I saw the other time is odd because of my experience. All right. So we have various machine learning algorithms that we'll look at. One, we have the classification algorithm, we have the regression algorithm, and we have the clustering algorithm. Classification algorithm, which falls under supervised learning. Classification is used when the output you're looking for is a yes or no, or in the form A or B, or true or false. The various algorithms that fall under this classification algorithm, one, the decision tree. We'll take this one after the other, and of course, we'll write a bit of code. We'll go deeper into this course in our next class. So, one, the decision tree, the naive Bayes algorithm, okay, the random forest algorithm, then the KNN, the K nearest neighbor algorithm. Whereas the regression algorithm, when the predicted data is numerically related, such as the storekeepers want to predict the price of a product based on demand. So you can say, okay, based on this demand, maybe let's assume now that the demand for apple is much because people feel apple can cure a particular disease, okay? So we now say, okay, by the end of this month, what will be the demand for apple? Or let's say, okay, a storekeeper makes $10 today, tomorrow it makes $20. Then we now say, okay, on the 14th day of this month, let's assume today is the first day of the month, what sales will the storekeeper make? So that's falls under regression algorithm. Here we have linear regression, we have lasso regression, and a lot of other algorithms that we'll talk about. Whereas clustering is a type of unsupervised learning that is used when the data have to be organized to find patterns. In the case of product recommendation, another application of clustering is in search engines, which studies search history to figure out your preference. Clustering, of course, most of us have Instagram page. Then you can see that, oh, you're just searching for a vendor that sells hair, let's say human hair. And before you even know, you're still thinking of it, you can now see some other vendors. It happens to a lot of us many times on Instagram. You now see that the Instagram is suggesting to you many other hair vendors, or let's assume you want to change your phone, many other phone vendors on Instagram. Then you just realize that every time you log in on Instagram, a lot of hair vendors are just popping up. That's because of clustering algorithm that has been written. Okay, so here we have a popular algorithm here is the K-mean algorithm. Okay, so moving forward, in today's class, these are the algorithms that we'll look at. The K nearest neighbor algorithm, the linear regression, the decision tree that use the yes or no statement, and the naive Bayes algorithm. That's a probabilistic algorithm to say, oh, in this new instance that I don't have, what will be my outcome, or predict if there's a new instance, what will I do in this new instance? Okay, so let's take it one after the other. The K nearest neighbor algorithm. Now look at this. Look at this data. So we have a data here, this blue data. We have another data. We have another data. Okay. So let's assume now that I now have a new data here, and I want to group this data. Does it fall under this blue data, or this red data, or this green data? And that's where the K nearest neighbor algorithm, grouping to the nearest neighbor. Okay. So I have a K nearest neighbor algorithm works in a way that a new data point is assigned to a neighboring group it is most similar to, okay? In K nearest neighbor, K can be an integer greater than 1, okay? So for every new data point we want to classify, we put to which neighboring group is closest to. For example, now I have this data, like I said, which is known as football. Then I have another new data. I have another new data, this green data, which is tennis. Then I have another new data, which is basketball. So let's take, for instance, there is a new data point. Let's take, for instance, I will just write here. Let's take, for instance, there is a new data point here. So I want to know if this new data point, if this new data is actually a football or a tennis or basketball, tennis, or football. Okay. So how do I do it? How does this algorithm work theoretically? Before we go forward, how does this algorithm work? What I just need to do is to either get my ruler or my protractor and measure. Let's assume now there's this new data point. So now I can just measure with my protractor. Now let's do this. Okay. So, of course, circular motion. This is not circular because I just used my marker to do that. The circular. So from now, I can see now that three balls fall inside this, whereas we have one, two, three inside this. Of course, we have one, two, three inside this. In this case, now we cannot group it, okay? But let's take for instance, if this was perfect and I do this, yeah. So now to know where this data point belongs now, we have three basketball inside this circular motion. We have two tennis ball inside the circular motion, whereas we have three football inside it. Of course, this is not a perfect circle. This should have been in the circle, but we use our protractor to get a circular motion. So now I can now say using K now will now be how many data are inside? How many data are inside the circular? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So choosing K as 10. Then this new data point is a football because football has four data inside. Okay. So let's just take for instance, I measure a circular motion and I say take K equals to 13. So I want to have 13 data inside this circular motion. Okay. So let's just assume I have 13 now. Okay. Now again, I can now measure. So when K is 13, let's assume, let's see if I have 13 data inside 1, 2, 3, inside 4, 5, 6, 7, 8, 9, 10, 11. So just 11. If I still make this circular motion bigger, most likely this and this will fall inside. Okay. So when this makes 13. Okay. So now in this instance, now let's assume this falls inside now. So in this instance now, when K is equal to 13, then 1, 2, 3 inside, 1, 2, 3, 4, 5 is inside, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 4, 5 is inside. In this particular situation, when I choose K as 13, if this is a perfect circle, then of course, this cannot be concluded using K nearest neighbor algorithm. But of course, let's take for instance, K is 11. I can say, because I know I've done this theoretically before, K being 11, I can say the data point belongs to tennis ball. Because I know this 5 data comes inside, whereas these 3 here, so I can say it's tennis ball. Okay. Moving forward, linear regression. Okay. Linear regression is to predict an outcome of what will happen in a particular day using some variables that have been known. All right. So linear regression analysis is used to predict the value of a variable based on the value of another variable. For example, let's look at these values to have a relation between x and y. So in this case now, apology. Let's take an example in linear regression. Okay. So example 1, using the machine learning regression algorithm, predict exactly how much sales will be made by a chocolate seller on Valentine's Day. As we know, Valentine's Day being February 14th. Okay, so these are the data we have. Days in February. On the first day, the chocolate seller made $1.3. On second day, the chocolate seller made $3.5. On the third day, made $5.8, and so on. On the seventh day, he made $17.6. Okay, so solution now. I come up with this table. I get my x, my y, my x square, my y square, and my xy. Okay, for x, I put all the data here. For y, I put all the data here. For x square, the square of this 1 times 1, that's 1, 2 times 2, that's 4, 3 times 3, that's 9, and so on and so forth. For y square, I didn't bother to do it because it's not needed in my formula. For xy, multiplication of this and this, 1 times 1.3, 1.3 then, and so on and so forth. So I do the summation of all of these. Summation of these, when you add all this together, gives us 28. When I add all this together, 65.9. When I sum all this together, it gives me 140. The summation of xy is this with 344. Okay. So going forward, I use my formula for the slope. That is m. M is equal to n summation xy minus summation x multiplied by summation y, all divided by n summation x squared minus summation x all square. Okay. So from there, I come up with this. So number of data, n being the number, in this case 7. 1, 2, 3, 4, 5, 6, 7. We have 7 data here, so that is my n. N multiplied by xy, I use this, that's 344. So 7 multiplied by 344. Apology, that's a mistake there. So 7 multiplied by 344 minus 28, summation of x, this is 28, multiplied by summation of y 65.9. So 7 multiplied by 344 minus 28 multiplied by 65.9, okay? All divided by 7, all divided by summation of n, that is 7, summation of x squared. This, I will use this 140, summation of x squared, so 140 minus summation of x, I will use this 28, all square. So get the cash. This is x squared, this is x, 28 squared. So using that equation, I will get 2.87143 as my slope, my hem. Then from there, I can calculate my my y-intercept, that is b, which gives me the formula summation of y minus the slope multiplied by summation of x, all divided by n, number of data, which is 7. In this case, I have summation of y. I use the 65.9 minus my slope, 2.87143, multiplied by summation of x, this is 28, divided by n, number of variable, which is 7 in this case. I get a minus sign, minus 2.0174. So the formula is y is equal to mx plus b, m being the slope, b is the y-intercept. Okay, so now I have my equation of function gives me y is equal to 2.87143 x minus, because of the minus sign that we have here, okay, because of the minus sign we have here, so minus 2.0174. This becomes my equation of function, which I have to use to calculate the variables. Okay, so when y is 14, when x is 14, sorry, so I mean on the 14th day, Valentine's Day, February 14th, for those of us that know that day. So when y is 14, when x is 14, what becomes my y? So here now I substitute my x into this. It gives me 2.87143 multiplied by 14 minus 2.0174 is equal to 38.183 sales. So it says on the 14th day in February, the chocolate seller will make $38.183. Okay, and this is how the linear regression algorithm is calculated theoretically before we input that into our Python data. Okay, so another algorithm is a decision tree algorithm that uses the yes or no or the true or false as a response. A decision tree is a graph that uses a branching method to illustrate every possible outcome of a decision. Okay, so I have a question: what condition or decision should be met for someone to stay indoors? Now I have it. Is it sunny? Yes. Then I go to swim. Okay. Is it sunny? If the response is no, then I go further by saying, is it raining? Yes. Then I stay indoor. Okay. We can have a lot of instances with decision tree. Let's say I want to predict if this person have fever. So I can just start with, just as a random example, do you have headache? Yes. Are you stooling? Yes. Do you have loss of appetite? Yes. Then you have fever. I can go further by say, oh, are you stooling? Yes. Do you have bitter tongue? No. Then you are pregnant. Okay. So the medical doctors, the clinicians, many people use decision tree algorithm. So it's just similar to this. During the next class, we'll talk more on decision tree and how to use the algorithm. Going forward, naive-bayes algorithm. This is a classifier algorithm. It's a probabilistic algorithm which we use to predict what's it called? We used to predict a possible instance that is not given on the table. Let's say, for instance, the naive-bayes algorithm classifier technique is based on conditional probability and is particularly treated when the complexity of the input is high. So now, how to predict? If I send an email to someone, will this email go into the inbox or the spam? So predict if this mail is spam or not, if this mail will go to the spam or not. So what it may be is the theorem said the probability of C happening when A has already happened is equal to probability of A over C multiplied by probability of C, or divided by probability of A happening. Okay, I'll take this one after the other. So like I have an example, determine on which day to play cricket. Now I say the weather is sunny, is cloudy, is let's say sunny, is cloudy, is windy. Okay, is it raining? Yes. Is it windy? Yes. Then play cricket. Then if I have this as no, don't play cricket, we'll take an example of that. So now as an example, let's look at this. We have 8 instances. These are the instances. Instance 1 to 8 instances. 4 attributes. What are the attributes? In this instance, we have the attribute can be color, bum bum, bum bum. I represent maybe a lady that has a big behind. Bum bum, height, nail. And what is the outcome? The outcome, it can either be a man or a female. Okay, so first we need to estimate the conditional probability of each attribute. Color, bum bum, hair, and height. For these species, classes, that is male and female, using the table given there. So we have here, using the probabilities, estimate the probability value for a new instance. So if there's an instance, let's say color is green, okay, bum bum is big, height is tall, and nail is having an artificial nail. What would that person be, a man or a female? A man or a woman, okay? And we don't have that instance on this table. None of these 8 instances have this particular, none of these same instances have this particular attribute, okay? Color green, bum bum big, height tall, nail artificial. So we want to predict where does it belong to? Will it be a man, a male, or a female? So we have 2 possible outcomes, male or female. We have 4 attributes, color, bum bum, height, and nail. We have 8 instances, okay? So how do I solve this? I come up with my conditional probability. Now I say the probability of it being a man. I look at how many instances, 8 instances. How many of those instances are male? 1, 2, 3, 4. So 4 over 8. Okay, probability of a male, 4 over 8, that's 0.5. Probability of female, how many of these instances are female? 1, 2, 3, 4. 4 over 8, that's 0.5, okay? So now I come up with my conditional probability. I do it for all the attributes. Here we have 4 attributes. So for color, we have 2 different possible outcomes. It can either be white, it can either be white rather, or green. So for it's man and female. So now, how many people are white color and they are male? White color. So this is white. You trace it there. 1. Another white. 2. This is white. Okay, not that female. This is so now. This is 2 over 4 because the male here is 4. 1, 2, 3, 4. So 2 over 4. How many white are female? I come to my table. I trace it. White. That's male. White. That's male. White. So this is white. Female 1. White, female 2. White, female 3. So now that is 3 over 4. So for female, we have 3 over 4. For male, we have 2 over 5. 2 over 4. I come to green. How many green are male? 1, 2. This green, that's female. So 2 over 4. How many green are female? I come here. 1, okay. So now that is 1 over 4. So we have my first table. I do the same for this. How many for height? So we have short and tall. How many people are short and they are male? Short, that's 1. Another short, 2, 3. So 3 over 4, okay? I do for female. How many people are short and they are female? Okay? So 1, that's 1. 2, 2 over 4. I do for tall. How many people are tall and they are male? 1. So that is 1 over 4. I do for female. How many people are tall and they are female? 1, 2. Okay. So for there I've gotten this table the same way I do for the bum bum. How many bum bum are big and they are male? I count how many bum bum are small and they are male. How many bum bum are small and they are female? How many bum bum are big and they are female? So I do for the same way I do for nail. How many people have artificial nails and they are male? How many people have artificial nails and they are female? I look at the table. So having done that, I come with this naive Bayes algorithm for male. So in this is how do I calculate the probability of it being a male? So it's a probability of male first. So now this is the instance. Using the naive Bayes algorithm, estimate the probability value for the new instance. Color is green, bum bum is big, height is tall, nail is artificial. That's because we don't have the instance in any of this table. Okay, if you trace it, color is green. Okay, color is green, bum bum is big, color is green. No one has that exact instance. That is why we're using this probability to predict this new instance, what will it be? Will it be a man or a female or a woman? Okay. So probably so now I say the algorithm says probability of male is equal to naive Bayes for male is equal to probability of male multiplied by, then we come to color green. Color green. How many color? What's the probability of color being green and a male? So 2 over 4, I put my 2 over 4 here. I come to the instance bum big for man, I do bum big for man 2 over 4, I put my 2 over 4 here. I come for height tall for man, I come to this place, height tall for man 1 over 4, I put my 1 over 4 here. Then I come here nail artificial, okay, for man, nail artificial 3 over 4, I put my 3 over 4. All gives me 0.02344, okay. I do the same for female. For this instance, probability of female first I had it is 0.5. 0.5 I put here multiplied by probability of color green from female. When it's green and female, 1.5, I put 1 over 4, sorry. 1 over 4, I put it there. When the bum is big and it's a female, when the bum is big and it's a female, that's 2 over 4. I put my 2 over 4 here. When the height is tall and it's a female, when the height is tall and it's a female, that's 2 over 4. I put my 2 over 4 here. And when the nail is artificial and it's a female, when the nail is artificial and it's a 1 over 4, I put my 1 over 4. So I get 0.00781, okay. So probability of it being male, I use this formula. I say naive base of male all over naive base of male plus naive base of female. So this is this all over a summation of this. It gives me 0.750008. I do the same for female. Naive base for female all over naive base for female plus naive base for male. That is this 0.0078. This is this 0.007, all divided by the summation of this and this. So for there I get 0.24992. So looking at this now, of course the addition of this must be always 1. So when you are doing your calculation and it's not 1, then you're wrong. So looking at this 2 now, when I sum it together, it's 1. So which one is the greatest? This is the greatest. 0.75 is greater than 0.24. So I say in this instance, when male is this is greater than female, hence this instance is a male. So in this instance, when the color is green, the bum is big, the height is tall, the nail is artificial, then definitely it's a male. So that is how this algorithm is being done. Okay, so having gotten that now, so let's do this exercise 2 together, okay? Do with me this exercise. So using the naive Bayes algorithm, what should I do in this instance? Outlook sunny, temperature cool, humidity is high, wind is strong. So then what is the possible outcome? Either I make love or I don't make love, okay? Either I'm making love to my girlfriend, my wife, or my husband, you know? So when the outlook, we have 3 conditional probability for outlook. We have the sunny, we have the overcast, we have rain. We have 3 possible outcome for temperature conditional probability, sorry. We have the hot, mild, and cold. Then for humidity, we have high and normal. For wind, we have strong and weak, okay? For the outcome now, is either I make love or I don't make love. So in this instance, which is not provided on the table, we have 14 instances. This instance is not there. So in this instance, what should I do? Should I make love or not? So do it with me and let us have the solution together in our next class. Thank you so much. Have a nice day.